today we have the session on multilingual zero-shot learning. So this is a talk delivering by Dr. Sunny Rai Madam, Mahindra University, Hyderabad. I welcome Dr. Sunny Rai Madam to this Friday sponsored ATAL FDP on exploring machine learning and deep learning techniques for natural language processing application. A very good afternoon from Department of Information Technology, VNR Vignana Jyoti ma'am. Good afternoon, ma'am. Sunny Rai ma'am.
Good afternoon, Dr. Revati.
Yeah, ma'am. And yes, we have now the session on multilingual zero-shot learning, and it is a hands-on session. So before hand over the session to Dr. Sunny Rai Madam, let me introduce Madam to all the participants. Dr. Sunny Rai Madam is an assistant professor in Ecole Central School of Engineering at Mahindra University, Hyderabad, and she did her PhD in Computer Science Engineering from Faculty of Technology, University of Delhi. Her area of interest includes natural language processing, social computing, and machine learning techniques. And Dr. Sunny Rai ma'am is a member of Association for Computing Missionary and Association of Computational Linguistics. Her research has been published in top journals and conferences like ACM Computing Service and Computer Journal, Meta for NLP. And Dr. Sunny Rai ma'am also have reviewed papers for reputed journals such as Neurocomputing, LCO, Computer Applications for Engineering Education, and top conferences such as AACL and EMNLP. With this long list of achievements and glory, may I now call upon Dr. Sunny Rai ma'am to take the session on multilingual zero-shot learning, a hands-on session. Ma'am, we request you to take over the session. Over to you, ma'am.
Thanks, Revati, very much for the kind introduction. I first of all thank VNR Vigna Jyoti Institute for providing me this opportunity to interact with you guys and to share my experience and my prior knowledge on zero-shot multilingual learning. So, Revati already mentioned that it is going to be a hands-on session. So I'll share a notebook on Google Colab with you, and I'll paste the link on chat box, and from there you can access it. But before that, to give you an overview about the concept of transfer learning as well as zero-shot transfer learning, I'll first start with the PPT, and as and when required, we will move to the Google Colab notebook. Okay. And if you have any question, please feel free to ask. You can interrupt me anytime, or you can also raise your hand. I may not be able to see the chat box. So if you're writing your query in the chat box, I will rather suggest that you raise your hand and just ask the question. Okay, so
Yeah, sure. I'll be there in the session as a moderator. So if any questions are posted in the chat window or any participants are raising their hand, definitely will inform to you, ma'am.
okay, thanks a lot, Evie.
Yeah, ma'am.
So I'll share my screen. So I'll start with the PPT first. So is my screen visible to you guys?
Yeah, ma'am. You can continue.
Okay, so the topic, as already mentioned by Revati, it's multilingual zero-shot learning, and we will go word by word about each component in the title. First of all, I would like to ask the participant about their expectation, or about their experience from NLP. So I'll just ask how many of you. You can also raise your hand. Actually, how many of you actually think that they have above average knowledge about NLP? So if you can raise your hand, accordingly, I'll improvise my explanation to make sure that everyone understands. So can I assume that you all know about the basic concepts of NLP and how to train a classifier, what is classification, what is representation, and all those things?
Yeah, I request participants to please post answers in your chat window because as this is a hands-on session, maybe this session is very interactive. As madam is asking something, please be interactive and you give the reply in the chat window rather than switching on your mic and saying something. You can give so that ma'am will continue that. Thank you, ma'am. You can.
Yeah. Okay, you can, if you are feeling, reluctant, you can just raise your hand. There is this button on the bottom of your screen. I'm moving my cursor around it. If you can just click on this button, I will have an idea how many participants have a basic idea of NLP, so that accordingly I can move forward with my explanation. Probably they are feeling sleepy after lunch. Okay,
No,
so
ma'am, not like that. They'll give the replay. As in chat window, they are giving, ma'am.
okay,
They're
okay.
having some basic knowledge about NLP as this is a elementary sessions, no, ma'am. So might be.
Okay, okay. So Kalpana has mentioned that she has a basic knowledge of NLP. Okay. So I have got two answers. So therefore, I'm going to assume that you know the basic concepts as well as the recent concepts such as encoder, decoder, and your word representation or word embedding. So let's go back to our slides. Uh, so in this particular session, we will discuss about the motivation. Why do we need to do this zero shot learning? Then the notion of transfer learning in NLP, some of you might be already aware what do we mean by transfer learning, and we will see the use case of word to vec as well as multilingual BERT. I actually got the opportunity to attend the previous session in some parts, and I heard that the professor was actually discussing about the BERT model and attention mechanism. So I think you can just borrow that knowledge from there, and it will be helpful in this session also. And then finally we will move to zero shot learning. After having a brief idea about the multilingual word, we have an activity planned for you, so you can actually run the model, where we will be training the sentiment classification for Hindi text, and then you can simply use it for other languages such as Telugu or Farsi or English or anything else, whatever you can think of. And then eventually we will go to the zero shot learning, and here also I have a small demo for you, but not so much activity here. This will be the main component. Okay, so I'll start. So first of all, traditional deep learning models, they need huge annotated data set. So we have discussed different models, right? In the previous lecture also, the professor was discussing about RNNs. Then he was talking about encoder decoder architecture, which was your actually transformer, right? And but it was also mentioned, and I think yesterday also one of you guys raised this point, that in case of deep learning you require huge amount of data to learn any task, right? In case of traditional learning models, the problem was handcrafted features. So even if you have not so big data, but still you will have to spend time on manually crafting the features, and if you have done a good job there, your model will still do a decent amount of it will provide a decent amount of performance. But in the problem with deep learning models is that definitely it gives you superior performance, but the problem is it will require very huge data set. Now why? Because you have multiple layers. So you have this input layer, and then after that you can have n number of hidden layers, right, which actually helps you to learn the abstract representation of the input. So for example, if I have something like the movie was good, right? So I would like to learn the representation for these words. Then further I would like to learn the abstract representation of what does this text mean using this hidden layer. And finally there will be softmax layer, which will give you probability for class 0 or 1, where 0 can mean positive class and your 1 can mean negative class. So you will get some probability. So if the result is something like 0.89 here in positive and rest 1 minus 0.89 in negative, because it's a probability, the sum will be equals to 1. So in that case you can say that this particular input is actually positive. So that is how we used to train and learn, right? But as I again mentioning that it will require huge amount of annotated data set. What do we mean by annotated? It will have sample plus label. So movie was good, positive. Movie was bad, it will be marked as negative, and so on. So you can think of reviews also. So if you have hotels on TripAdvisor, so you can look at the reviews, and then you can have a classification system where it will mark whether the review is positive or negative. So this is what we were doing for a long time, but eventually people realized that this thing does not scale well for low resourced, or the cases where you do not have sufficient label data. So for example, in case of the movie reviews, you have website like your website like IMDb, where people are giving rating also, right? So you will give stars. So if the movie has more than 3 stars, you by default assume that this is going to be a positive review. If the if a particular movie has less than 3 stars or 3 star, you say that it is just average or below average. So kind of negative review. So it helped you in extracting the label data set, which served as label data set for you to learn the classification. Now, in some of the cases, this might not be the case. For example, if I want to perform metaphor detection, now, can you tell me what is metaphor? One of you can explain me what is metaphor. Metaphor is the simple your figurative speech in English. So here basically what happens, you conceptualize concept A and B. Now, if I want to create a system which will detect metaphor in text. So for example, my car drinks gasoline. Okay. So in this case, versus my car consumes gasoline or petrol. You can say whatever. Now here this is literal use of the word, whereas this one is metaphorical use of the word. Why? Because car is an inanimate object and it cannot really drink, right? So therefore this phrase is actually metaphorical, this phrase is non-metaphorical. So similar to positive negative classification, I can perform text classification with respect to metaphoricity as well. But in this case, getting the label data is not so easy. For the positive negative, because there are so many use cases, you will eventually have sufficient number of sample points to understand what do we mean by positive and what do we mean by negative. But in case of metaphor, especially if you move to low resource language such as Hindi or Telugu, it will become even more difficult. For Telugu, for instance, even getting the positive negative example is not so easy. So the people started thinking, so once you have done enough amount of work in English, people started thinking about the low resource language, and then they realized that they do not really have the sufficient amount of data. So what should we do about this? So then traditional ML techniques actually learn each task from scratch. Now, what do we mean by that? So you will have, for example, you have task A. It could be anything. It could be text classification. It could be text generation. It could be, hate speech classification, anything. So now you will first require this label data set. Then you will train a model. Now this model could be your traditional ML model. It could be deep learning model. But the idea is that you will have to train from the scratch, and then finally you will learn how should I classify this objects, right? Likewise for model B also, you will again take the whole set of annotated data set. For example, if this is for sentiment classification and maybe this is for hate speech recognition, in that case again I'll be starting from the basic. But the thing is, when you think of humans, they do not work like that, right? If they know how what is positive, what is negative, after that if they want to, if they are asked the question whether this particular task is hate or not, and I'm also giving the definition of hate, in that way they will learn that hate is something which is going to have negative meaning, which is going to have anger, which is going to have something offensive, right? So just by giving the description, they will learn from their prior experience of sentiment, right? But in case of machine traditional ML techniques, what happens, that you will again teach the machine from the scratch what do they mean by hate, and it won't really capture the meaning of sentiment. Likewise here, it captures the meaning of sentiment, but it doesn't understand that texts which are expressing anger could be a subset of, could be a superset of hate. That means hate is eventually going to express anger, or disgust, or something condescending, right? So the question is again, if you have another text another task C, and if you do not have the sufficient number of instances, you won't be able to train your model. But what if we can use this information which we have already learned during training model A, during training model B? Can we import this information and try to learn this model C? Am I making sense? If you have any doubt, please stop me and ask there only. Okay. So what do we mean by transfer learning? Transfer learning basically says that the prior information which you have gained while training the previous models, can you take that information and incorporate while learning a new task the way humans or animals do? So for example, if I already know that maybe horse look like horse is an animal with four legs, and it has a tail, and it is used for horse riding and all those cases. And somewhere I read that even zebra, it has it looks very similar to horse, but it has black and white stripes, right? So even when I have not seen zebra before, the moment I see it, I'll be able to recognize zebra, right? This is what is transfer learning. So I'm capturing my information about the horse as well as a description. What does a zebra look like? And then I'm combining both of this information to identify completely new task on which I was not really trained. So basically, transfer learning says that given a source domain DS and a learning task TS. So basically, you can assume that maybe you are doing hate speech classification. So you have this data set on hate speech. It will have instance plus the label, and the learning task is to classify whether a particular text is a hate speech or not a hate speech. A target domain DT, which is completely new task. Okay, so maybe this was on hate speech, maybe this is on sentiment, completely different task. And learning task TT, transfer learning aims to help improve the learning of the target predictive function FT in DT using the knowledge in DS and TS. So the thing which you have learned while training this task, you basically import that information to learn the model for target domain DT, for which you may not have the sufficient number of annotated data. So you are basically importing this knowledge learned from here to here, so that you can classify this task also, which is my TT, in target domain. But even with very few example sentences or label data. So this is what we mean by transfer learning. Is there any question till now? Okay, so let's move to the next step. So how do we do transfer learning in NLP? Now, I would like you guys to, speak up at this point, because you have been doing a lot of sessions in this FTP on deep learning techniques, and I am sure you must have learned something like word representations and, sequence modeling and so on. So now, can you tell me? Now, I have explained you the notion of transfer learning. Can you tell me the? Can you tell me a use case which you can think of can be used to perform transfer learning in NLP? So this is basically the gist of transfer learning. Your previous learning from different tasks T1, T2, T3 up to Tn minus 1, and this n could be any number. You use this learning to learn task Tn, which is which may not have labeled data set, but it is somehow related. It cannot be completely unrelated. So of course, if I have learned only Hindi language, and if someone asks me to do maths, it is completely unrelated. I cannot really borrow my understanding of Hindi language to perform mathematics. So that there has to be some kind of interrelationship between tasks, so that language can information can be transferred. Now, did you see any such use case in NLP in the previous session which you have done in this FDP, where information, some modeling or some learning done in the previous task was used in downstream NLP task? No? Okay. So your general language representation on unlabeled data learned using self-supervised learning, and then this representation used to perform tasks such as sentiment classification or text classification or generation or anything, it's a transfer learning, right? So you must have seen in the previous session that your other instructors or professor were discussing about word to wake model, glove model, and they were saying that these embeddings can be used as feature forward. So for example, the movie was good, right? So I can simply import the embedding, word to wake embedding for the word the, likewise for the word movie, likewise for the word was, and then I can feed this set of features into a model, right? Again, this model could be your traditional ML model. So for example, you can simply train a SVM model, or it could be your deep learning model, for example, recurrent neural network, and then you will finally get this result. So what is the probability for class 0, what is the probability for class 1? So the learning which was done to create word representation is being transferred to perform sentiment classification. Okay, so I'll do a very brief recap of word to wake. So word to wake is basically your dense static word embedding. So it was mentioned earlier also. What do we mean by static? So it has a fixed embedding for each word in the vocabulary. So normally it is not such a bad thing, but if you have ambiguous word, so for example, bank, right? So bank can mean financial bank as well as river bank. So but this word to vec, it has only one embedding, right? So it is not actually capable of distinguish between financial versus river bank. So not capable of performing word sense disambiguation, that means finding the right sense of a given word according to the context in which it was used. Now it has another word, self supervision. So why like we said in the beginning only, we are saying that the shortcoming of the deep learning model is that it requires huge amount of annotated data set, and most of the time for low resource languages and as well as for new tasks, you do not really have that amount of training data to train a very good deep learning model. So people realize that actually you can use the data itself as a supervised task. So if I have something like the movie was shot in America, so I can say that movie and short, they are somehow related because they are occurring together in a context window of keywords, and therefore I can infer what are the words which are close and what are the words which are not so close, contextually close and contextually not close. So this is what they mean by self supervision. So you are using the data itself to identify true context word versus not true context word. So therefore implicitly labeled data, that means you are not actually labeling the data, but by per se the data is labeled when you talk about the contextualness of a word. This embedding, as you might be already knowing, that it is capable of capturing different types of syntactic as well as semantic relationships such as synonymy, analogy, sentiment, gender, tense, part of speech, and so on. So intuition of skip gram model. So in word to vec, you have two model. One is skip gram model and another is continuous bag of word model. So in case of skip gram model, what happens? You are passing one word, and the model predicts various contextual words. So maybe word one, word two. This is my word X and word three, and so on. It will give the probability of word one occurring in context of word WX. Likewise, probability of word 2 occurring in context of wx, and so on. Likewise, context bag of word, what happens, it basically does the opposite. So you will give a set of words, and then there is this one masked word or hidden word which is not told to the model, and the model job is to predict this hidden word which was masked. So therefore, what is the right word which can be substituted here? So in case of skipgram, basically what we say that instead of counting how often target the word W occurs near a context word C, we basically train a logistic classifier saying that are you likely to see this W1 in context of WX? And therefore you learn the semantic representation of the word. So the words which are closer to context word X, they will come nearby. So for example, word W1, W2, W3, and those words which are further from WX, they will be presented somewhere here. So you will basically learn a semantic space from where you can actually use the semantic similarity measure to identify the relatedness between any two words. Now you can easily identify the true context word from the corpus, right? So because the movie was short, so I can take each pair, for example, the movie, movie was, movie short, and so on. And I can say that these are true context. That means my true samples or positive samples. But what about the negative samples? So by just looking at the corpus, I cannot really create the negative sample. So in this paper, they propose this very interesting, technique where they say that to create false context word, what we can do is we can randomly pick words which did not occur in context of movie, for example. So if I have, for example, movie and the word maybe sanitizer, okay, so because I never saw this word sanitizer in context of movie, I can randomly pick those words which were not present in this context and say that this will serve as a negative sample or false sample. So what will happen? I would like to bring together words like movie, short, actor, maybe location, okay, and the words like sanitizer, they will be pushed apart. So that is what this word to vec is doing. So what will happen? So for example, if you have this text, everything which is occurring in context of maybe this any word, for example, apricot, it will occur as a positive sample, and everything which did not occur in context of apricot will serve as negative sample. In word to vec, especially for every positive sample, they created k negative sample. So for example, apricot, tablespoon, because they occur in context window of maybe 5, k is equal to 5. That means tablespoon, word tablespoon was present within distance of 5 words from apricot. So for this thing only, you will create two examples. So apricot artwork, apricot 7. So these are the words which were never occurred in context of apricot. So therefore they serve as negative example and this one serve as positive example. So that is what we mean by self supervision. So you can see that I did not really label the data, but I use the data itself to create positive and negative samples. So finally, for the loss function, you will, what do you want to do? You want to maximize the similarity between the target word and the context word pair, so those which are true context, and you want to minimize the similarity between word and the false context word. So that is what the relation is. Why this product thing? Because for every positive symbol, a positive sample, you have k number of negative samples. So you want to maximize this. That means it's a negative sample, and you want to maximize this also. So this is your basic word to vec. I hope it is clear to everyone. I'll show you some figures. So you can see that this is a link, a projector.tensorflow.org, where you can go and you can actually click on the word to vec. I can actually show you this. So for example, if I go here, tensor, this is the website. So here I can choose options. So for example, word to vec embeddings, I say word to vec all, and then I can so this is taking some time, but let's see. So it's computing PCA. So PCA is principal component analysis, but we realize that we, with very high dimension data, for example, these word to vec representation, you normally prefer TSNE model. So TSNE model actually helps you in understanding the clusters in much more clearer way than PCA. I think you must be aware of this already. So now if I search any word, for example, let's say car, I can choose this word car, and so you can see you are getting different car models, right? Motorcycle, ship, trains, because they belong to the same category of vehicle. Then you have different models were also shown earlier: Honda, Chevrolet, Skoda, and so on. and then you have driver, then you have industries because car are made in industry, and so on. Expensive cars are expensive. So you will see that this is actually rotating in different dimension. You will get different neighbors. So these are the top closest one. So here you are getting the models. So this is your word to vec embedding. So basically all those words which are semantically close, they will be pushed together. So they will become neighbors of each other, and the words which are not semantically close, they will become far. Okay. So for example, if I pick this word, this is in some other language, but let's pick like socio-linguistic or teams. Okay. So in case of team, you will see that all the words, so you can see that they look further away, but actually this is a very high dimensional space. So these are the ones which are closest to it: team, club, army, career, program, move, and so on. Likewise, if I click on league, again you will see words like team, scoring, basketball, MLB, and so on. And then you have losing also, then you have the also. So it, you can understand that this basically helps you in arranging the semantically closer words. uh, the embeddings will be arranged in such way that the words which are contextually common, they will come together, and those which are not so common in context, they will be pushed further away. Likewise, you will see that in using this word to vec embeddings, you can also capture a syntactic relation. So for example, the word slow, slower, slowest. Likewise, short, shorter, shortest. And you will see that the difference between slow and slower and short and shorter is actually very similar. Likewise, slower and slowest, shorter and shortest, the distance between them is similar. So that is how you can also learn analogy relationship. So you can have this slower and slowest, shorter than what is shorter. So you basically add this distance to shorter, and you will get the shortest part also. So you will be able to learn analogy relation as well. Likewise, here you can see semantic relationship. For example, brother, sister, nephew, niece, uncle, aunt. Likewise, man, women, sir, madam, and then you have king, queen, countess, earl, and so on. Okay, emperor, duchess, empress, duke, duchess. So all these relationship can be learned just by using this unlabeled data. Now what is the catch? So because initially we were complaining that we do not have the labeled data, therefore we cannot really perform deep learning. Now this problem is solved, right? You can always get the unlabeled data. Even for the Telugu, if you want to work in Telugu language, you can simply collect the digital archives of newspaper articles or book articles, and you can simply train them and create a word to vec representation for Telugu language. Okay. Now, this can also be used to learn semantic shift between words. So, what do we mean by semantic shift? Semantic shift basically means that the meaning of word actually changes after a period of time. So, initially, the word gay in 1900s, it meant something sweet, cheerful, flaunting, daft, and so on. In 1950s, also it meant witty, bright, and so on. And 1990s, it became lesbian, bisexual, homosexual, right? Likewise, the broadcast meaning of broadcast in 1850 meant something else. And then in 1900 it actually changed and become something related to the media such as newspaper, television. And then finally in 1990s, broadcast was very closely related to BBC. Likewise, you can see this word awful, how the meaning of the word awful has changed over a period of time. So even you can use word to vec, and you can train the model on a time slices. So you can train on corpus published in 1900s, 1950s, from 1900 to 1940, and then 1950 to 1980s, and then finally 1990 to so on. And you will see by looking at the neighborhood of the word, for example gay here, you will learn that how the meaning has changed over a period of time. So what is my aim behind telling you all this? That just by using this unlabeled corpus, we were able to learn different kind of relationship which can be used in the downstream task. So for example, if I want to perform word sense disambiguation or sentiment classification, because I know that the word maybe joy will be closely related to maybe movies, plays, or maybe eating or dinner, because all these things were joyful dinner. I had a joyful dinner. The movie was very good, and it gave me lot of joy, and so on. So I will learn that eating, playing, and watching movie, all these are joyful activities. And if I see a word such as we went for a movie, and if I want to know the sentiment, or the inherent emotion behind it, I can simply say that okay, maybe it is something related to joyful activity, right? And we went for maybe if I say we went for work, probably not so joyful activity for some of the people. So this is something which can be learned even when you do not have the sufficient amount of labeled data set to train this information. You can simply use the word to vec representation as the starting point, which will capture all this information and then perform the classification task on top of it. Okay, so this is what we mean by transfer learning. So, same thing can be used for various downstream NLP tasks, for example, sentiment analysis, part of speech tagging, text classification, and so on. But the problem with this word to vec embedding is it does not capture contextual information. So you will basically have same representation for river bank and financial bank. But this was something which was recognized very early, and people work towards resolving this problem. And more recently, the objective is to create universal language agnostic representation. So in the case of word to vec, you were dealing at word level, right? You were creating pairs, word context pairs, and then you were trying to classify whether it is a true context or false context. But people realize that if you are working on word in isolation, you won't be able to understand the different senses a word can have, and therefore you will only have a fixed static embedding. So eventually people move towards sentence embeddings. Okay, so this multilingual word works at sentence level, and this is something which is trained on 104 languages. So you will have Hindi, you will have English, you will have French, you will have Spanish, and so on, many other language. And similar models are GPT 1, 2, 3 by Open AI, then uh, ULM fit, then you have Laser, Robota, TF5. All these are multilingual models. That means you can actually, even if you are working on Telugu language or Tamil language or Marathi language, for which you may not have sufficient amount of label data, or maybe you are thinking of hand labeling the data set for a particular task, still you can use this model, import the embeddings for your text, on which you can perform the transfer learning and then learn the task. Okay, so we will briefly discuss this multilingual board, and after that we have this small collab notebook which we will do. So in case of multilingual BERT, it basically stands for multilingual bidirectional encoder representation from transformer. So you already know about transformer. It's a stack of your encoder decoder, but in this particular BERT model they have used encoder components. Bidirectional, that means it can consider left to right context as well as right to left context, so it will go both way. Now I will give you an example to make you understand why this is important. So for example, I don't have money, let's go to bank. Okay, okay, in this case, because this money has occurred before, I can learn from here and I can interpret the meaning of bank. But I can also have this way, like let's go to bank, I need to withdraw. Now in this case, until and unless till this point, I won't be able to finalize the sense of the word bank, whether we are referring to financial bank or river bank. But as soon as I read the next sentence, I will be able to point out that okay, this is referring to financial bank, not the river bank, because withdrawal is an activity which normally happens at a bank, financial bank, right? So this will require you to go right to left. So this BERT model actually uses this knowledge and perform left to right modeling as well as right to left modeling. So therefore bidirectional. And why multilingual? Because it is actually trained for one, not four languages, different languages. Okay, so now let's see. So here I'm just going to give you intuition in brief. What does word do? So in case of word, the task is to predict the original vocabulary ID. So as you might be already knowing that every word in your corpus is assigned an ID. So for example, the movie was, so it will be assigned some number, maybe 101, 102, and so on. This is the vocabulary ID. So it basically, the task is to predict the original vocabulary ID, or basically the word of the randomly masked word based only on its context. So if you give a sentence as an input, the movie was, and then there is, this is masked, I don't know, okay, in Japan. Now what, guess what should be the word? What do you think should be the word here? Any guesses? What do you think should be? Can you please repeat?
Um,
Just think any word. I mean, you guys know English, right?
yes.
The movie was Dash in Japan.
It may be hit in Japan or it may be created in Japan.
Yeah, perfect. So it can be created in Japan, shot in Japan, or hit in Japan. Anything. It could be anything. But these are the words which are likely ones, right? So that is what we are doing. We are masking this word, and we are training the model to predict the right word here, the possible word which can be placed here. So of course, you will, in the output you will tell that it could be hit, it could be short, and so on. And the model will learn the word which it predicted, how far symmetrically, how far was it from the word hit or short. Okay, and accordingly it will back propagate it, it will update the parameters, and next time it will try to predict a word which is much closer to the one which are given as the target word. Do you understand this? So this is very similar to the language modeling thing which we do. And then next, sentence prediction. So in this case, actually input can be sentence pair also. So sentence one, sentence two. So basically it learns that what is the probability of seeing sentence two after sentence one, if it is a right sentence or not a right sentence. So in the way we discuss in word to vec, where you were categorizing true context word pair versus not true, not true context word pairs. Likewise, here also you can say that this sentence 2 actually follows sentence 1. And you can also randomly create false cases where sentence 2 will be something random, completely unrelated to sentence 1. That is how it will learn the semantic correlation between the words. So this is basically your word model. It's basically a single language model. So language model, what is, do you guys know what is a language model?
Some program which can understand it,
Program which can understand.
the input and the output, or you may say which can predict the output from the input.
So yeah, you are somewhat close. So basically what happens, language model, given a sequence of word, it predicts the next sequence, or actually it predicts the probability, joint probability of word sequence. For example, word 2, 3, and so on. How likely are we to see this combination of word? Or for example, if I say that the movie was, this is my input, okay, then what is the probability of seeing the word short, or hit, or maybe located, or maybe cooked? So the cooked is a word which is very unlikely, so it will get very small, negligible probability. But these words like short, hit, or located, or these words, they are kind of likely words, right? So they will get relatively higher probability. So the language model, basically it's something which gives you the likelihood of a sentence, or likelihood of a group of sequence, likelihood of a sequence of word in given a language. So in English language, what is the probability of saying the movie was short? Likewise, in the French, accordingly, the sentence will be translated, and what is the probability of seeing that. So you can actually guess that language model is very important, even in the tasks such as machine translation, because you do not want to create weird sentences. So, for example, if I give you this example, I like strong tea. Okay. Now, if I convert this to Hindi, even if you try it, for example, let me do it for you. So if I go here and open Google Translate and I say I like strong tea, okay, and then I say that convert it to Hindi. So it's saying मुझे मजबूत चाय पसंद है, but those who know Hindi, they know that this is not how we convey strong tea. We say kadak chai, right? Likewise, if you convert it to Telugu, and I don't know Telugu, so you guys will have to confirm whether it is correct or not. So this is I can't really pronounce it, but you guys can read and tell me if it is the right translation or not.
I don't know Telugu.
You don't know Telugu? Anyone who knows Telugu, can they verify with if it is the
If
right translation?
if you give in Kannada, I can tell, ma'am.
Okay, Kannada. Okay. So we can do Kannada also. So this one.
No, it's wrong, ma'am.
What does it say?
It says like it is actually translating strong as Balwan kind of thing.
Yeah, exactly.
So
So even in case of Hindi, when it says majboot, again it has the same connotation of balwan, or structurally strong. The way
structurally strong, yes, that way.
structurally strong.
Physically strong.
Physically
Physically
strong.
strong, but this is not how we convey strong tea, right? We have this word kadak chai in
Yes,
Hindi.
yes.
Likewise, it will be the case for Telugu and Tamil also. So this language model actually helps you in understanding this also. So if I write majboot chai, it will say it has very low likelihood. You don't really see this kind of combination in corpus. So this actually helps you in picking the words which are
This,
colloquially used.
ma'am, this is the problem with Google Maps also, ma'am.
Okay. What
In
happened?
if you see in Kannada and English,
Uh-huh.
uh, I mean, I don't know. Many people would have observed in their own local languages. When you try to give that name in English, actually, what is the spelling? As per that, only it translates into Kannada. Doesn't take the meaning or anything like that. So there is no semantics involved in that.
Yeah. So
It just substitutes that English letters to Kannada alphabet. That's it.
So the thing is, because probably Tamil, Telugu, Kannada, not much work has been done there, but still Microsoft India is doing a lot of work for Indic language translation. But still, like I am saying now, you know that you have these models, multilingual BERT, or word to vec, which you can basically train on your language without really relying on the supervised data, and you can create downstream applications. So the thing is, motivation behind this whole lecture is that to encourage you guys that you can work on your own language, because
Yes,
most
yes.
of most of us are working on English language. For English language, you have very good resources, you can do almost everything there. But when you move to languages Assamese, or Hindi or Bengali or Manipuri, you don't have anything there. Hindi is still doing better because a large portion of society speaks Hindi. So there are still tools which work very well there. But you can see even in Google Translate, it is not doing a very good job there. Okay. So this language model, it is a very important component to understand the nitty gritties of a language. So the way it is spoken. So I'll show you the BERT model. So I think in the last lecture you discussed, there is this encoder, and then there is this attention head, and so on. So this is your sentence one, this is your sentence two. You are trying to understand whether sentence B follows sentence A or not. And this is the underlying architecture. You will have there are two types: BERT base versus word large. So BERT base, it actually has 12 transformer blocks, 768 hidden layers. So basically you will have 768 layers here, and then it has total parameters of 110 million. And then you have this BERT large also. It has 24 transformer blocks, it has 1024 hidden layers, 16 attention head, and total parameters of 340 million. So now you can imagine it's a huge language model. Okay, and the thing is, most of us may not even have the sufficient resources to train something like this from scratch. So it's always better to use these representation, because the kind of data they have, the kind of computational training they have already done to learn those representation, it's very very difficult to improve upon that. So it's better you use that embedding or projection and you work on top of it. So that is the idea behind transfer learning. Now, in this case particular, because you are working at sentence level, so you learn contextual embeddings, unlike your word to vec where you had static embeddings. That means for one word you only have one representation. So here the word mouse, uh, basically it represents like a conical structure. In all direction you may get different meaning. So you have mouse, it could be cheese loving mouse, it could be fast moving mouse, it can be click on the mouse. So this is your computer component, this is your animal mouse, and this one fast moving mouse again is an animal, right? So it will be able to differentiate between all these mouse. And if you give a sentence, for example, cheese loving mouse, this representation will be different from this representation. Okay, but in case of word to vec, whether you have this thing before mouse or whether you have this thing before mouse, the representation will be actually same representation will be imported. So that is one advantage. And very important thing is, BERT model is actually capable of delivering state of the art performance. So this is also known as SOTA. So in many paper you will see this word SOTA. So SOTA basically means state of the art performance for different NLP tasks after fine tuning. Now we will see what is fine tuning. Fine tuning basically means that once you have this for example, once you have this pre-training, you learn the representation. So for every word you have this real valued vector. Okay, maybe 0.01, 1.34 and so on. You have, it could be any dimension. I am not really sure, but in case of word to vec it is normally 300 dimension, but I don't know what is the dimension here. So it basically gives you this real valued vector for the word the, mouse, movie, and so on, for all those words. Now what happens is, once you have this pre-training representation, this is the most expensive part. So this is something which needs to be done one time, and it is actually also present on your Hugging Face library. So after that there is this component of fine tuning, which basically says that you can use this representation, and using a small set of training data you can fine tune these embeddings. When we say fine tune, you basically means update the parameters so that it classify these tasks more efficiently. So NER stands for named entity recognition. It is your multilingual natural language inference. So NLI stands for natural language inference. So you want to understand, for example, entailment. So there is this hypothesis and then there is a premise. So does the hypothesis follow the premise? Likewise, squad, I think it's squad is for translation. Is it so? Or question answering? I think it's question answering. Yes. So this is the task of question answering. So basically, using these representation, you can train any kind of task. For my own research purpose, I fine-tuned BERT model to perform metaphor detection. So basically we collected huge amount of tweets, and then we fine tune the BERT model on a small set of metaphor samples, and then we actually use this model to identify tweets which are metaphorical. So basically in a way to augment our data set. So now earlier I had only maybe 2k instances of metaphorical sentences. Now using these tweets and this fine tuning model, I have 20,000 metaphorical instances, which I can further process and see. And I can further go for hand annotation. So initially maybe I had this 1 lakh tweets. So if I wanted to even do hand annotation, I have to do it for 1 lakh tweets. But now because I have this BERT model, I can do this basic classification. I can identify the most likely metaphorical tweets, and it says that it is only 20k. So further to improve upon the data set, I can do hand annotation on 20k. So I have actually reduced my effort significantly. So this is one of the use case to augment data. Okay, but you can also try different things. using this BERT model. So, okay. So need label data sort for the target downstream application. And now we are going to do this activity of sentiment classification by fine tuning BERT model. So I'm going to share the link with you. I have pasted the link in chat box. You click on this link and try to access the notebook. I would suggest you to not make changes, but just to try. If you want to make change, create your own copy and then make the change. Okay, so this particular file requires this another Hindi data set which I'll have to share. Revati ma'am, are you there? So I want to share a file. Should I email?
Yeah, 1 minute, madam. I will send a Revati madam mail, madam.
Okay. So that way it can be sent to all the participants because here I don't think I can attach file. Okay, Kalpana said that it is giving correct translation in Marathi. So that means in Marathi they have done much better work in comparison to Kannada. So Dr. Srinivas, shall I send the file to you and you can then forward it to participants? It's a data file.
Yes, madam. Yes, madam. Okay.
Okay, so I'll email it to you. Okay, so Dr. Rao will send the file to you. Meanwhile, we can start. So I'll open my file. So sentiment analysis with BERT it has lot of details. So because we are short of time, so I'm not going to go through each module in very much detail. But you can. It's very comprehensive and it's very detailed. So you will have all the components, and as well as you will have enough information about each component as well. Okay, so I would request you to read it in more detailed manner when you are done with this session. But let's start. So I have already executed because it takes around 10 to 15 minutes to complete the training time, so I'm not going to run it live, but these are the results which we can show. So basically this is your NVIDIA thing because you want to create this deep learning, so you have this GPU architecture which is required. You can read this. We have already discussed this mass language modeling as well as next sentence prediction in the slides. uh, Now you basically install transformer. So it's a set of architecture which is available in this Hugging Face library. You will have different models also, BERT, Robota, and T5, and many others which are released. So this is your basic setup, the color palette, the libraries which you will require. So for example, NumPy, Panda, Seaborn for visualization, Matplot, sklearn, and so on. This seed thing is basically set for reproducibility of the result. So because when you are partitioning the data, if you do not set seed value, most of the time what will happen, you will get different participation in each iteration and your results will not be reproducible because it's not the same partition anymore. So the file which I sent you, when you run this particular block of code, it will ask you to browse and add the file, and there you can just choose the file which I have sent, Hindi sentiment, and upload it, and this will work fine. So this particular file, the data which I have shared with you, uh, it comprises of only Hindi reviews. And what we are trying to do is we are trying to use this multilingual BERT fine tuned on Hindi dataset, but still capable of predicting sentiment in case of Telugu language. So that is what we are trying to understand here, that using the notion of transfer learning, even when you do not have the sufficient number of positive negative example for Telugu thing, but maybe you have it for Hindi language, so you can use just this multilingual BERT, which actually associate same words in Hindi and Telugu language together. Okay, so it knows that, for example, this word X in Hindi and word Y in Telugu, it means the same thing according to its representation. So the concept which it is learning for which it is learning through Hindi data set, it will be still applicable for the Telugu, Tamil or Kannada data set. So these are your some example sentence. For example, यूपी में बड़े स्तर पर दंगे करवा सकती है बीजेपी. These are combination of your tweets as well as reviews. So गुमनाम है वतन पर मिटने वाले लोग and so on. I mean, it doesn't have the complete text, but these are some examples. It has total 6,428 sentences and 3 columns. So first one is your text, and then you have this sentiment label, and then this 0 indicates negative, 1 indicates positive. Class name, negative, positive, you will see the distribution of samples. So you have somewhere slightly less number of negative tweets when compared with the positive, but almost balanced. So in some of the cases the data set is highly imbalanced, that means you have only 10% of positive class and rest of it is negative. There probably you will have to perform oversampling and try some other ways to increase the subset of positive sample. Otherwise what you can do, you can modify the metric, or there is also another library where the small class is given more weightage, so you can also try that method. This is your basic data processing, and here you can see I am using BERT base multilingual cased. So as we discussed, that BERT has two models version, one is base and another is large. Here we have only used the base one, which has 764 hidden layers, but the bigger one, it has around 1024 hidden layers, and it is significantly bigger in size. Multilingual, that means it will work for 104 languages. You can see the complete list of language on the Google. And when we, what do we mean by cased? So cased basically means alphabetical order is maintained. So the words which are capital and the words which are not in uppercase, they are treated differently. If it is uncased, that basically means that both are same. Then BERT has its own tokenizer, because in the case of BERT model, tokenization is actually implemented using this notion of byte pair encoding. So this is not simple breaking the text using the space idea. So most of the time when we perform tokenization in NLTK, what do? We see the space. For example, the movie, there is a space between these two words, and we break the word. So the will become different and movie will become different. But most of the deep learning models, language model, they go for byte pair encoding, which has a slightly different way of breaking the components, and it actually learns the sub characters representation. And that is why it can also work for words which are not present in your vocabulary, or in your corpus. For example, when you are fine tuning, maybe some word were not present, but if you see those words in test corpus, because the representation word learned on sub word level, it will still be able to predict the meaning of those words. So this is your basic some text to explain you the process of tokenization. So for example, the weather in Hyderabad these days is truly unpredictable. So if you run this tokenizer, you will have sentence. The tokens are like this: the weather in Hyderabad these days is truly unpredictable. So you can see that these three, the word unpredictable is tokenized in slightly different manner. So you can read about this thing called I will write it here only, byte pair encoding. So that is the intuition behind this kind of break in the text. And each word will have a vocabulary ID. So for example, this word the, it is 10117, weather 35660, and so on. That is what we mean by original vocabulary ID. And it has some special tokens. So for example, separator, ending of sentence is indicated by number 102. Likewise, if you are going to perform classification, in the beginning of the input only you add this token 101 to indicate that this particular instance is actually used for classification. And then you have padding and so on. So actually I'm going to go through this quickly because I want to cover zero shot also. So finally encoding will be performed, and you have this attention mask. So initially all the words are given attention of 1, that means all are equally important, but gradually the system will learn some words will be given more score and some word will be given less score. This is your tokenizer. So I will just go to the bottommost part because we have less time. So you can just go through this, run it, it will work. So when you train this model, I want to just show you one thing here. So this is just basic training part. You will get something like training accuracy versus validation accuracy, evaluation, and then finally what I want to show you is this part. So predicting on raw text. So you can see that I use the BERT based multilingual model. I fine tuned the BERT model using Hindi text. But for example, if you see this uh, I can't read it. So it's in Telugu. Okay, probably it means movie was bad, I think, because it has something similar. Now, I did not use Telugu when I was fine tuning my model, but still it will be able to learn this thing. So you can see that if I run, actually I ran it already, I think. Yes. So if I run this thing for review text, this one, you will see that it gives you the sentiment negative. But the most surprising part is I never used Telugu in my training corpus during the fine tuning part, but still it is capable of predicting, making prediction on the by learning just from the Hindi text. Likewise, you can do it for Kannada also. Likewise, you can do for Tamil also, and many other Malayali, many other languages as well. So this is your multilingual word. Okay. Now we will quickly discuss the notion of zero shot learning. So what do we mean by zero shot learning? So fine tuning, easy to adapt to any downstream NLP task. It could be hate speech, metaphor, topic categorization, part of speech tagging. You can do part of speech tagging for maybe Malayali language or Tamil language. And but the disadvantage is that annotated data for fine tuning itself is a challenge. So even when you are saying that you will require 2K instances to perform fine tuning, which is of course a very big change from the initial set. So when you train a deep learning model, we say that until and unless you have something in order of 10K, don't even think about using deep learning model, because your model will not really gain. It's better to go for traditional machine learning method, right? But because of this transfer learning concept, now you don't really need 10K or more than 10K. You can just go ahead with 2K and still you will get very good results. But the question is, sometimes it's even difficult to get this 2K data samples. Now what if we can fine tune without annotated data, or just few examples, maybe one or two? Okay. So this notion is called meta learning or learning to learn. It's a learning paradigm which aims to create models that can learn new skills or adapt to new tasks rapidly from few training examples. In context of language model, basically what we mean, model should develop a broad set of skills and pattern recognition abilities. Okay, so that when you are, when you want to perform inference or prediction, just by using one or two or maybe zero examples, you should be able to get the result. Now, zero shot learning. So zero shot learning is basically being able to solve a task despite not having received any training examples of that task. So for example, if I want to perform sentiment classification, I use this multilingual BERT. Okay, but I don't want to fine tune at all. I want to simply give the my input from the test set, and it should be able to give me result. That is what we mean by zero shot learning. Okay. So for example, you have text samples with class label, which is your train set, and then text sample without class label, which is zero shot set. To find class labels for zero shot data set, even if these classes did not occur in the train set. So the example of Telugu, which I showed you, it is actually zero shot learning for the Telugu language. So now the question is, imagine that you have never seen a hateful text in Chinese, but you have seen hate samples in English. So you have an understanding of what is hate, okay, and how does it look in English language. But again, if you talk about the Chinese, the characters are different, but the underlying idea should be same, right? Here also people must be, behaving in a rude manner to someone, and in Chinese also the person will be behaving in offensive manner. So the underlying idea is same. So if I know how does hate look like in English, can I also identify hateful text in Chinese? That is what we mean by zero shot thing, even when I have not seen Chinese before. So is it possible to associate observed and non-observed classes through some form of? Okay, how much time do I have? So right now it's 3:15. I need some time for question answering also. So Dr. Revati, can you tell me how much time can I take?
Actual time is 3:30, madam. You take
Hmm.
half an hour, no problem.
Okay. So what we are saying is, in case of zero shot learning, the objective is that you have some kind of samples or labels in your training set. So for example, if I'm doing cat and dog classification, in my training set I have examples of cat and dog. So these are pictures of cat and dog, okay? This is cat and this is dog. So now the thing is, in my test set, if I have animal like fox, okay, this is something which was never seen in my training set. Now can I still predict that this is a fox? That is the question. That is the idea behind zero shot learning. So you want to predict classes or labels which you did not see in training set, okay? Now, so the question is it possible to associate observed and non-observed classes? So cat, dog, these are observed classes. Fox is something which is unobserved class. Now is it possible to associate observed and non-observed classes through some form of auxiliary information which encodes distinguished properties of class? So if in some way I can find out how is cat related to fox, or how is dog related to fox, and or how are they different, I'll be able to make the prediction for fox also. So if I know that this is how cat looks, this is how dog looks, and this is how fox should look, so I'll be able to say that okay, this is not really cat, this is not really dog, so maybe this is a fox. So initially, even now the traditional algorithms basically treat the target labels as mere symbols void of any inherent semantics. So for example, if I'm saying that sample point 1, sample point 2, sample point 3, it is maybe cat, this is dog, this is cat, but this is something like 0 or 1, right? You do not really use the label information while training. But what if we treat labels and its textual description as semantic units? So what if I say that cat is something, it has four legs, it has two eyes, it has soft fur, it has claws, it is it can be cause of allergy and so on. So this is some description of cat. Likewise for the dog also, I can create a description of dog. And why don't I learn this description and create an embedding, and then basically find the similarity between the sample, this one samples S1, and this textual description. So even if I see some unseen sample, unseen class, if I have the description, I can still figure out the similarity or closeness between them, and then I can be able to predict whether this particular representation belongs to this class, or though the class representation for the cat, or the representation for the dog, right? So that is what we are trying to understand here. So in 2013, there was this work by Google, where they proposed that actually, for object detection in images, we can we can use the labels and their textual descriptors while training, and that is how we will calculate similarity between them. So for example, this is your traditional visual model where you have image, you have some, some number of hidden layers and some architecture, and basically you are learning the label whether this particular image belongs to class cat or dog. Okay, or you can have fox also, multi label class. So you have cat, dog, fox. Now the thing is, earlier we were doing like this. Now what if I learn the representation for cat, dog, fox from word to vec model? So this is your skipgram word to vec model. Now I have, instead of using cat or zero, what I will do, I will use this real valued vector representation as label, and then I have this label, I have this image, I take this embedding, I take this embedding, I calculate the cosine distance between them. The, for example, with if this image is x, so what is the cosine distance between x and cat? What is the cosine distance between x and dog? What is the cosine distance between x and fox? Okay, and whichever is getting the lower distance, that means that particular class is the closest to x, and I can simply predict that this particular image falls into class maybe fox, even when I did not see the fox class in the training data set. Am I making sense? Do you guys have any question here? No.
Ma'am, if it doesn't know about fox, it knows about only dog and cat, then how it can say that it belongs to fox?
Yeah, because we are using textual description of fox. We are saying that we are going to use this label also. So in the earlier machine learning algorithms, this label did not serve any purpose, right? It was something like 0, 1, 2, 3. You did not really went behind understanding the semantic meaning of the label. What is a cat, or what is a dog, or what is a fox? So in this particular approach, what they said is, rather than using these labels as just a symbol, why don't we learn the meaning behind them? Okay, does it make sense?
So basically, information of fox is there either in text form or in
Yeah,
any other form,
yeah,
but
exactly.
information is there.
So this, the description of fox will be there. So maybe you can use Wikipedia articles or some other source and identify what do we mean by fox, what is the definition of fox. Okay, and then you see what is the definition of cat, what is the definition of dog, and when you get some image, you see the similarity, how close this image is to cat, how close is this image to dog, how close this image to fox. You will learn this joint embedding space. Okay, it will become clear in the next slide. So for example, now in the previous example in 2013, it was basically for objects in images, but in 2016 this guy modified this approach for text classification. And what he did, so initially we had this x image, right? Now he's saying that it's not image but it's a text, maybe word 1, word 2, word 3, up to wn. So this is my text. I will learn the embeddings of this sentence. I will learn the embeddings of my class. For example, this is description of fox, this is description of dog, this is description of cat, and I will learn how close they are. Okay, and the description and the class, whichever give me the closest distance, that will be the right class for it. So argmax C. So this set of C could be dog, cat, fox, right? Maybe we have three classes. I learned the sentence embeddings. I also learned the class embedding. So I have this description of dog. So it may have sentence 1, sentence 2, sentence 3. In 3-line description of dog, likewise I have 3-line description of cat. Likewise I have 3-line description of fox. So what is I'm trying to do is, now I'm not really, relying on the labels. I'm relying on the semantic meaning behind those labels. Is it clear? Okay, we will let's go to the next slide and see. And more recently, Yen et al. In 2019, he proposed that rather than calculating the semantic distance between your text or your sample as well as the class, why don't you convert this problem to a entailment problem? Okay, so maybe for example, this is an example text. The plague in Mongolia occurring last week has caused more than 1,000 isolation. Now, you can have different levels of classification. You can classify on the basis of emotion, you can classify on the basis of topic, you can also classify on the basis of situation, and there could be many other possible labels. So if you talk about the topic, you will have health, finance, politics, sports, etc. For emotion, you can have anger, joy, sadness, fear, disgust, and so on. Likewise, for the situation, it could be shelter, water, medical assistance, anything else, right? So what this guy is saying, that I'm going to convert this task classification, text classification, into entailment. Now we will see what do we mean by entailment. So textual entailment basically is a directional relation between text fragments. So you will have this premise, and then you have hypothesis, okay, or your text or hypothesis. The first sentence, you basically want to see whether hypothesis follows the text or not, or text follows the hypothesis or not. So for example, if you help the needy, God will reward you, and hypothesis is giving meaning money to a poor man has good consequences. So you can see that text and hypothesis are related. So there is a positive textual entailment between hypothesis and text. And the example of negative textual entailment, or basically contradiction, is if you help the needy, God will reward you. Giving money to a poor man has no consequences. So if this is the hypothesis, this does not entail, right? So therefore it's a contradiction. Both sentences are not following each other, but in this case they are following each other. If you help, you will have good consequences, and reward is a good consequence, right? So therefore this hypothesis in this text entails hypothesis, whereas here this text does not entail hypothesis. So therefore this is a negative textual entailment or contradiction, and this is your positive textual entailment. So what this guy Yin said, that rather than calculating the distance between the class label and the text, what I can do is I can convert the whole task as well. So for example, if I want to perform topic classification, what I can say is that this is the text. The plague in Mongolia occurring last week has caused more than 1,000 isolation. Now if I want to perform topic classification, what I can simply say is this text is about health, finance, or health. Maybe this text is about health or finance or politics. So all these will be separate hypotheses, and then I will simply say whether this thing follows this or not, if it is a positive textual entailment or not. If it is a positive textual entailment for the health, then I can simply say that this falls into the category of health. If it is, for example, emotion aspect, this text expresses anger. Next hypothesis could be this text expresses joy. Next hypothesis will be this text expresses sadness. And then I will see what does it express. Does it express sadness? In that case, I will say that this belongs to the class of sadness, and so on. You can have different criteria. For situation aspect, you will have the people there require, need shelter or water or medical assistant and situation. So with respect to the situation, you can further perform classification. So this is something which was proposed, and in 2019 only, and it is gaining lot of traction. Lot of work is focused on teaching the task and model itself. So we will see this. I will show you this. Let's open this and see. So this is the app of zero short topic classification using the notion of textual entailment. So I can create my own example. So for example, I can say zero short learning talks about not using supervised data set. Okay, this is a text which I have created. Now I want to classify. I can have one topic could be machine learning, right? Another could be nature, maybe. Okay, and if I just do enter, you will see that I created the topics itself. I create it is my own text, right? And probably this particular language model, it is using GPT-3 I GPT-3. So it's using this model BERT MNLI. I can also choose different models. So you can use Roberta, you can use this one also, Yahoo, trained on Yahoo Answers. So but the thing is, you learn that with 84% probability, it's saying that 84% confident is it is saying that it lies into the notion of machine learning. Now I can use something else also. For example, aloe vera is translucent. Translucent. Okay. Now I can have machine learning and nature. So now you can see that it comes under nature, 94.6. So this is your zero shot classification. Because of the using of this property of textual entailment, it gives you immense scope to expand your model for different use cases. Now we will briefly discuss this GPT. We don't really have time, but let's see. So I'm going to skip this. So in case of GPT-3, it's again a language model similar to your BERT model, but in case of BERT, it was bi-directional encoder. In case of GPT, it is an auto-regressive language model. When we say auto-regressive, basically what it means, the last prediction is actually used as a part of input for the next cycle, next prediction. So it performs in context learning. What do we mean by that? That when you are giving the text input, you basically also provide a task specification. So translate English to French. This is your task description. And then you give some examples. So for example, sea otter, peppermint, plush giraffe, and then it is translating it to French. And then this is 3 examples. So basically this is your few short learning. So you must have also heard of one shot learning, few shot learning, and then finally you have zero shot learning. So in case of few shot learning, you give k number of examples. In case of one shot learning, you just give one example, and in case of zero shot learning, there is no example when you want to make the predictions. So just by specifying the task also with the input, you are basically performing in context learning. Your language model will eventually learn what does it mean when you say translate English to French. What does it mean when you say that text generation, or maybe what does it mean when you say classification? What does it mean when you say that whether it entails the premise or not? Okay, so this is capable, this GPT-3 is capable of zero shot transfer learning, that is performing NLP task without any fine tuning. So you can see that your BERT model was like this. So when you give this example of sea otter, it will update the parameters, and then further with the second example, again it will update the parameters, and for your k number of example, k number of time updation will happen, and finally you will have this fine tuned parameters which you can use for the downstream NLP task. But in case of zero shot, just translate English to French and then the word is given, and you have to model will be predicting the French version of cheese. Likewise, for the one shot, one example is given, and then cheese will be converted to French. Likewise, for few shot, you give k number of examples. Here k is equal to 3. Okay, so this is the thing, and there is a small demo. So again the transformer, and then you choose this pipeline of zero shot classification, and then again you pass the sentence and the possible candidate label. Now this is the class of multi this is your multi-label classification, multi-class classification. Now there is also one other possibility where one sequence can have multiple classes. So in that case, you make this true, and then you see what is the probability for each class. So this is something which I can share with you, and you can run when after the session. So you can also write it like this movie was bad. Actually, I haven't run this, so I'll have to start from here. I'm going to do for here. Okay, it's taking time, but I'll share this link with you so you guys can create your own copy and try running this. So I have pasted the link in chat box. You can visit this link and try to run. I would suggest you to create your own copy before running. So now it's done. So I'm going to do it for this one, positive, negative. Maybe I rather than creating this label of positive, negative, maybe I should do it for cinema versus nature. The movie was about Mount Everest. I mean, this is a confusing one, right? So if I do this, so you will see that it's giving more probability to cinema. It's correct only, right? Uh, for example, if I say a movie needs to be made on Mount Everest, you are still getting cinema. Now let's say pollution is destroying Mount Everest. So you have nature as the prominent label. So that is what I'm trying to say. You can, because it is trying to understand the basically what will happen. Pollution is destroying Mount Everest, and this is about cinema, this is about nature, and it will try to understand whether the text entails the hypothesis or not. If it is not, then it will get very low probability, otherwise high probability. So using this property, we can actually create labels on the go. You can think of anything and still it will be able to perform classification, top text classification, sentiment, hate speech, and so on. Okay, I hope it was clear. And questions, now we are done with the session. So if you have any questions, please ask.
So,
Yeah,
ma'am, when you are
thank you
talking
so much,
about your
Sanirai ma'am, for this wonderful practical session. Now I invite the participants to post the queries, whatever they have regarding the session.
Thanks, Revati.
Yeah, ma'am.
am I audible?
Yes, you are audible.
So, ma'am, when you talk about zero shot learning, so that means we are not supervising, we are not giving any labels to our output.
Yes.
So, this is basically an example of unsupervised learning. Can I say that?
Unsupervised learning, okay, so there is this another category of unsupervised learning where you have the samples, and then you are still you even in unsupervised learning you have some kind of training, right? You are learning the clusters, and then further you compare with some kind of seed set to identify the labels. You don't really know what are the labels in case of unsupervised, right? So for example, if I have this movie reviews, okay, and if I cluster unsupervised way, I do not really know on which criteria I'm clustering. Am I clustering on the topic of movies? Maybe some movies are on sports, and some movies are on social causes. So maybe cluster could be formed on those criteria. Another possibility is movies review are positive and negative. One criteria could be this. So we don't really know, right, in case of unsupervised, but here you are actually giving the label, and you are actually able to directly understand the relation with the label also. Is it making sense?
Not much clear. In case of zero shot, how we are giving the label?
So because I'm specifying the labels, right, when I said cinema or nature, I gave the label. But in case of your unsupervised, your normal clustering algorithm, if you compare with them, you create the cluster hoping that this is the underlying criteria, classification criteria. So if you have, most of the examples are following the pattern of positive, negative, maybe you will get it. But maybe you can also get it on the basis of genre of the movie. So it could be adventurous, it could be romantic comedy. Even those could be valid clusters, right? Because in unsupervised you are just saying that similar samples will be clustered together, and dissimilar samples will be pushed further away, right?
Yeah,
Is it making sense?
I am trying to compare them, but I am not basically getting the real hidden concept between.
See, in case of unsupervised, what is the intuition? You are saying that similar samples, I don't know what is I'm going to just randomly pick a sample, and I'm going to pick another sample, and I'm going to see whether they are close or not. If they are close, I'm going to keep them together. If they are not, maybe there is a threshold distance, I'm going to keep them in separate buckets, right? There
Yeah.
is the concept of intercluster distance and intracluster distance, right? You
Yeah.
want to
Yeah.
maximize intercluster and you want to reduce intracluster.
Okay.
Okay, maybe you can read more about it, and if you have question, you can write to me.
Okay.
Yeah. Any other questions?
Yes, madam. Yeah. One of the participants, they have posted a query in chat window. Dr. Nishu Gupta ma'am, she is asking like, is there any research article published based on the similar work like whatever you have presented?
Yes, yes.
Or yeah, or maybe any of your publications, if possible, she is asking you to share it.
Okay, so I have submitted two papers where I have used word fine tuning. One was for metaphor. I'll quickly show. Okay, so this is still under review, so I cannot share, but I will show to you guys. So let me share my screen. And so okay. So this is one paper which we have submitted. COVID is war and vaccine is weapon. It basically on COVID-19 metaphors in India, and what we have used, so labeling metaphor from tweets. I mean, we had almost 19 lakh tweets, so it's not very easy, right? So we use word fine tuning basically to get this initial data augmentation. So I'll show you that part. So see here, filtering literal tweets. So we fine tune BERT model for training. We asked it. So basically, initially we created a small subset of metaphorical data set, for which we asked for which we perform human annotation. But then we use this small data set to identify metaphors from almost let me get the number. Mm, 1.3 million tweets. Okay, so if I manually label 1.3 million tweets, it will be very extensive work for me, right? But if I create just 3k metaphorical tweet data set, and then I use this 3k metaphorical data set to fine tune BERT model, which can later help me in identify the metaphorical tweets out of this 1.3 million, it reduces the task significantly. So that is what we did. And further, for the semantic drift concept, which I was showing you in the ppts also, so you can see that initially during the lockdown, the word COVID-19 was very closely related to battle, fight, war, attack, break, control, win, defeat, overcome, and so on. But later in the, if you compare with the, this one, second wave, you will see words like failure, lose, shield, deadly, dangerous, fear. These came closer, deadly virus. So the meaning of COVID-19 was gradually changing according to the metaphorical words which were used by the people. So this is one work where we use this word fine tuning. There was this another work where we actually used for identifying the needs on social media, and identifying how many needs were frustrated or fulfilled. So there is this concept of Maslow hierarchy of needs, and what we were trying to identify, we will extract the tweets. We will identify the tweets which are talking about the basic needs such as food, water, and then there are needs which are talking about education. Then there are needs which are talking about volunteering or charity, or maybe marriage, and so on. So we were trying to understand how many needs were actually fulfilled and how many were frustrated. So we actually saw that this blue line actually indicates the basic needs, the bottom one, safety and food and water. So these many number of tweets were posted which were expressing frustration about the basic tweets during the lockdown, and these many tweets were for the second wave. And likewise for the advanced need, you will see that even there the increase was there, but it was not that significant. Likewise, this is the proportion. So you will see that frustrated needs, almost 75% of the tweets were speaking about the basic needs getting unfulfilled. Likewise here, this spike actually indicates a September December time where it was about New Year and people were significantly frustrated about not able to go out, celebrate, and enjoy the New Year and so on. So this is again something where we use the bird fine tuning to identify the frustration among in the tweets. I hope it helps. I mean, if it gets published, if it gets accepted, I can put it on my website and you can read the whole paper from there. Anyway, you have this. You can see my slide.
Yeah, mom.
So here I have we have references also, so I can share these references with you, and you can refer them. The work which I have mentioned about the textual entailment, as well as finding the similarity between the class and the sample, it is this work. This one for the class similarity part, learning document label word representation jointly, and another work was by Yin. Uh, this one. So it basically benchmarking zero shot text classification. It modeled the problem as entailment, textual entailment. So if you read these two papers also, you will get a very good idea about the zero shot learning. Does it answer your question?
Yes, ma'am. Hope she got the answer from
Yes,
you.
ma'am. Yes, ma'am.
Yeah.
Okay.
Thank you, ma'am. Yeah, ma'am. Sunny, ma'am, is there any open access tool like to start with practicing what you have shown? So, any open access tool is there? Can you suggest?
Open access tool. So I don't really understand what you mean by tool.
I mean, the coding that we do,
Yes.
like the results and all that you have drawn just now, you showed in your upcoming paper.
Hmm.
Uh, on which
Okay.
tool? Yeah, you have you done all that?
Okay. So for this paper, actually, there are different. Let me see. So I'll. Okay, are you talking about this one?
Yeah, and like figure 9, figure 10, figure 11.
This is from your simple this results matplotlib. You get the numbers, and then basically you are plotting on the basis. It's like a time series: week 1, week 3, week 5, week 7, week 9. So how the volume of tweets changed over the period of time. So this is the analysis for 18 months.
Okay.
Okay, so in the first week there were only maybe this almost 3,000 tweets, basic needs, and then these many tweets for the advanced need. We have just plotted, and this is your trend analysis, the solid line. And this is actually, I think, some map view as viewer. This particular graph.
Yeah. Okay. Yeah.
Okay.
Yes, ma'am. Fine. Thank you.
Yeah.
Very informative presentation, ma'am.
Thank you very much.